to take a look at a digital console, and this is the Allen Heath SQ6, which is a very good console on a budget. I think it's like $5,000, $6,000 right now. It's got a lot of nice features. We're not going to repeat a whole lot of stuff that we already went over on the analog. I mean, there's some extra features that this does that an analog board doesn't do, but a lot of it is just what we already looked at. It's just rearranged, you access things in different ways. So for example, starting with the channel strip, because that's where we started over there, instead of having everything laid out with an individual channel strip for each fader, what I can do is I can select a channel, and actually, I'm going to grab the microphone I was using, plug that in as an example. Plug that into channel 1, and actually I need to change this to local for that to work, which I'll show you that in a second. Anyway, so we have our channels just like on the analog board. The channel strip is kind of in different places, it's scattered, so you don't have that nice visual that you have on the analog board, but you do have less controls, so it's cleaner, you can access things in different ways. But like if I select this channel here, well now up here this is the preamp for that. Or if I select this one, well now this is the preamp for that one, and so on and so forth. You have the preamp, then you have your EQ. Actually the EQ is over here. The high pass filter, remember the high pass filter is part of the preamp, so just like on the analog board, they're right next to each other. And I can turn it on, I can turn the high pass on and off here. Then your EQ is on the other side over here. This is a fully parametric EQ. So on the screen here, I have a representation of the channel strip with the preamp and the high pass filter and the EQ. I can tap on each thing and take a look at it. I can take a look at my preamp up here, and I can see on the screen how much I'm gaining it up. If I go to my EQ, if I tap on that, well now I have a visual representation of the EQ. And again, it's fully parametric, so I can select 4 different bands. I have a high frequency band, a high mid, low frequency. If I go to my high frequency, I can use this knob to select the frequency that I want to adjust. I can use the gain knob to boost it or lower it. And I can use the width knob to adjust the Q, or the width of that curve. Notice it is a bell curve. And these are actually all bell curves. Some of them I can change to a shelf if I so desire. The high frequency I can change to a shelf. I can toggle there. And the low frequency I can change to a shelf. So I can make it function more like that semi-parametric EQ did, where you have a shelf on each side and then a bell curve in the middle. Or I can make them all bell curves. I can make the high frequency a low pass filter. So that's the opposite of a high pass. And it's actually not part of the preamp in this case. This is actually part of the EQ. The high pass is still part of the preamp, but the low pass is part of the EQ if I do that. So yeah, I can select different shapes of how I'm adjusting the EQs. I can do bell curve, I can do shelf, I can do a pass filter, low pass or high pass. The middle ones, however, are just bell curves. It's fully parametric. It's more surgical. You can select the specific frequency. You can select the range around it that you're adjusting, and then you can gain it down or gain it up. So you have a lot more control over the EQ, and you have a nice visual here. I like starting with explaining on an analog console, because you have a nice visual of how the components are related to each other, with the signal going through the preamp first, and then your EQ and your effects and all that. You don't have as much of a visual of that here, but you do have a nice visual of what each thing is actually doing. I can really see what I'm doing with my EQ, which frequencies I'm adjusting. You have that nice graph of the spectrum there. So that's pretty handy. This has a compressor, which I can turn on here on the channel that I have selected, and then I can pull up a visual by tapping on the compressor there. So now I can actually see the different parameters. Unlike on the analog console, which was just a one knob compression, and the parameters change automatically as you turn that knob. Here I actually have control of all the individual parameters. So I can adjust the threshold. Let me just plug into a local channel so you can see this thing. So I'm going to select local 1, which I just plugged into. I'm going to gain it up on my preamp. Check, 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 check. You can see the signal there. I'm going to turn on the compressor, and if I have my threshold set way up here, the compressor will never activate. The compressor activates when the signal passes where the threshold is set. So as I move my threshold down and the signal starts to get past the threshold, then you see gain reduction taking place. You see this red meter here. That's the compressor pushing down on the signal. So I can adjust where the compressor activates, at what signal level the compressor will activate. I can also select which frequencies activate the compressor. Over here with the side chain. Some soundboards, it's called a key filter, but here it's a side chain. So I can turn on the side chain there. Digital boards, you'll have on and off buttons for a lot of the different components, or bypass buttons. So just watch out for that as well. My compressor is turned on this channel, and then I turn on the side chain, and I can adjust which frequencies are activating the compressor. So back to that example of the song that I'm working on right now, where I don't have the stems, I just have the track, and the kick is really out of control. One thing I'm doing to get more control of it is I have a compressor where the threshold is set just so that it catches the bump of the kick. And I'm watching the signal on that channel, so I can see where the kick is jumping up, and I have the threshold set so nothing else on the track is going above that point, only the kick. And then I also have a side chain filter or a key filter set on that compressor. I have it set really low, I think I have it at 60 hertz. Because I really just want the compressor to activate when the low frequencies, the rumble and boom of the kick, when that jumps up on the signal. So you can use a side chain filter to target specific frequencies to compress on your channel. You can also have it, this is called self-keyed. Right now I have it self-keyed, so its own signal is activating the compressor, but I can also sidechain it to something else. I can select the kick channel up here. So now the compressor is not activated by its own signal, it's activated by signal over here on the kick channel. So that's often used, for example, with a bass guitar, you might sidechain that to a kick drum. So every time the kick hits, the bass gets compressed, it gets ducked, and that just helps provide more distinction and clarity between the bass and the kick. And there's a rhythmic thrust that gets emphasized as it kicks, and the bass gets ducked down. So there's different ways to get the compressor to activate, by setting the threshold to a certain point, and by setting the side chain to a certain frequency or to a certain channel. Once the compressor activates, then you want to look at your ratio. And the ratio is going to determine how much compression is being applied. A 1-to-1 ratio is no compression. It's 1-to-1. What comes in goes out the same way. As you turn that ratio up, 2 to 1, 3 to 1, 4 to 1, 5 to 1. You can go really high, 10 to 1, 20 to 1, 60 to 1. Now that's even more and more compression. And you can see the visual again here. You can see the graph. When it's a 1 to 1, it's just a nice 45-degree angle. But then as you crank up the ratio, it starts to slope more and more horizontally. So it's compressing more and more. When you have it compressed completely horizontal, that's an infinite ratio, and that's called a limiter at that point. It's compressing so much that the signal cannot get past the threshold at all. It's an infinite ratio, whereas if you have a ratio of like say 4 to 1, well, it's going to get past the threshold a little bit, but for every 4 decibels, wait, let me see if I remember this correctly. For every 1 decibel it goes above the threshold, it gets compressed down 4. So the higher the ratio, the more it's going to get smushed down for each decibel it goes above. You also have attack and release parameters. So I can control how quickly the compressor activates. The fastest this one goes is 30 microseconds, so extremely fast. Within 30 microseconds, when the signal gets above that threshold, the compressor goes into effect. Or I can give it a slower attack. I can put this one all the way up to 300 milliseconds. I don't think I've ever done that before. I've done 30 microseconds before. But you can have more of a gradual effect. And then there's also a release control. This is how long does it take after the signal has gone below the threshold, how long does it take for it to stop compressing? And this can go as low as 50 milliseconds or as high as 2 seconds, 2,000 milliseconds, which I've also never done before. Where you set these, it depends on the shape of the waveform, the transient. So going back to the kick example, because a kick has a very sharp transient, it's a dynamic waveform, it just immediately shoots up. I'm going to want a faster attack on that. And because it's not a very sustained sound, it's just a hit, just a strike, I don't want the compressor to linger very long after that. So I'm going to use a fast attack and a faster release. So it goes into effect immediately as soon as that kick hits, and then it stops pretty quickly after that. Fast attack, fast release. Some instruments you might want something a little more subtle. So you slow down that attack a little bit. And if it's a more sustained sound, like the human voice, for example, well, you might not want the compression to back off so quickly. So use a slower release for that. So you got those controls there. There's also a knee. You can do a hard knee or a soft knee. And you can see the visual change to more of a curve. Sometimes if you have like an actual compressor unit, you'll see something called over easy, TM, or is it registered trademark? I forget. But
well done.
But over easy is basically just, it's a soft knee. So it's the amount of compression it applies changes depending on how far you're getting above the threshold. So it's more of a gradual change in the compression rather than a hard knee where the settings that you apply just apply all across the board whenever it gets across the threshold. So if you're going for a more subtle effect, over easy effect, you could put a soft knee on there. And there's also a parallel path. That's if you wanted to blend a compressed signal with the dry signal, you could do a parallel path there. So you have some more controls here versus the one knob compression. This also has a gate, which the analog board didn't have. A gate, strictly speaking, what a gate does, first I have to turn it on, remember, turn things on. You set a threshold, and where's my threshold here? There we go. You set a threshold, and anything below that threshold is not allowed through. So basically the gate closes below that threshold. And strictly speaking, that's what a gate does. It's a complete close. You do have a control here called depth. Sometimes it's called range, where you can have the gate not close all the way. You can have it close just a little bit, so it's not cutting off the signal, but it's just reducing the signal quite a bit. Here, that's called a gate. Strictly speaking, that's actually an expander. A gate cuts off the signal. An expander is just going to push it down by whatever amount you designate. Just like how I use compressors on pretty much everything, but with different settings, I also will put a gate on pretty much everything, but not cutting everything off. I'll use them more as expanders for the most part. So for example, vocal mics, I'll put an expander on pretty much everything, and I'll set the threshold to, I'll watch where the signal is jumping, and I'll try to set the threshold just below where the signal would be when they're actually on the mic. So that way the gate is activating, the gate is closing whenever they're not using it. But I'll set it as an expander. I won't have it close all the way. I'll just have it reduce just a few decibels. And that adds up if you do that on every single vocal channel. Just a few decibels, 3 decibels, 6 decibels, especially when you're summing them into a bus, it really makes a big difference. It can clean up a lot of your mix. There could be noise bleeding into those mics when they're not being used that you might not even notice, because it's just, you're in the room, you're hearing that noise acoustically unamplified, and then you're hearing it out of the PA, and you might not notice all the noise that's actually in the room that you're hearing. But when you start to put gates on things and knock down decibels just a little bit on channels when they're not being used, it can really clear things up in ways that you might not even realize were possible. So I like putting expanders and gates on just about everything. And that's really what it's for. It's to help cut down on noise that's unwanted bleed in microphones, like drum sets. There's so much bleed. There's only so much you can do, but you might gate the kick mic, for example, if you just want the sound of the kick and you don't want the sound of the cymbals or whatever. You put a threshold pretty high because the kick has a lot of energy. So the gate, and you might do an actual gate at that point, not just an expander. But you set the threshold so that the gate opens only when the kick is actually being hit. And just like on the compressor, you have attack settings that go down to like 50 microseconds really, really fast, or you can go up to like 300 milliseconds. You also have a release parameter. So I could use that. I could set that very quick attack, quick release, so you don't notice the gate. When the kick hits, you don't notice it. It just immediately opens. But then I'll have it close pretty quickly after the sound of the kick has finished, so that you're not hearing all the bleed of the cymbals and other drums. The gate, in this case, also has a hold parameter. So you got attack, release, and hold. The hold will adjust how long the gate remains open for.
So it's kind of like a door.
It's like a door. It's a gate. But it's a door that doesn't have to close all the way,
right,
if you don't want it to. If it closes part of the way, then technically it's an expander. Just like with a compressor, if you have an infinite ratio, technically at that point it's a limiter, not just a compressor. You got compressors, limiters, gates, expanders, and I'll use compressors on everything. I'll use gates on everything. It really helps clean things up. Gates help clean things up. Compressors help clear things up. As you're giving each thing its own little space. The gate can also be side chained, so you can do some cool effects with that. Like if you listen to EDM, you hear like it's called noise gating. You put some white noise and you side chain it to the kick, so when the kick hits the noise, the noise stops, and so you get this open closing effect. You'll hear that. That's done with a gate, a side chain gate. I don't know what context we would ever do that here, but for those of you,
the dubstep concert.
the dubstep concerts,
pretty lit.
EDM night.
Yay.
There was a like a acapella dubstep group that
What?
it's done a couple of performances here.
It's just like the beatboxing stuff, but like with their mouths.
Yeah,
That's cool.
They do their own noise gating with their mouths. Anyway, yeah, there you go. You got, just like on the analog board, you got your preamp. You have to select the channel, and then you can control it here. You can also tap it on the screen. And this is like a universal, this encoder here is like a universal control for different things that you tap on the screen. And you've got high pass filter, gates, compressor, EQ. But instead of it being all laid out with independent control for each channel strip, you have to actually click through menus. You have to select the channel, and then these controls control the channel strip for that channel. And there's things on the screen that you can select. Unlike the analog board, the fan and power is, you have individual fan and power control for each channel. So if I select the channel and I go to the preamp screen there, I can press and hold 48 volts, and then now fan and power is applied there. There's also a pad on each channel, again, press and hold. And now the signal is attenuated by 20 decibels, I think.
If you supply phantom power to every input, would it cause the board to have like less power?
No,
Or none?
it shouldn't. Yeah, I don't think it wouldn't mess up anything in terms of the performance of the board.
Right.
How does it generate?
That's an interesting question.
How does fan power generate?
It's generated by the preamp, and it's sent upstream up to the XLR cable on the ground, the ground wire.
That's cool.
Yeah, and then what you see on digital boards, remember we talked about gain and trim over on the analog board, and it's kind of interchangeable there. It's the same thing. Sometimes it's called gain, sometimes it's called trim. Except sometimes there's channels on the analog board that don't have a preamp, and then it's just trim at that point because there's no preamp. Well, on a digital board like this, you have gain and trim on every single channel. And basically what that is, the gain is the preamp. So the gain is like the physical circuit, the preamp in the board, and you're controlling the amplification there. The trim is digital amplification that takes place after the preamp. So kind of like optical zoom versus digital zoom for you film guys. And just like with optical zoom versus digital zoom, the optical zoom is preferable. So you set your gains first, and then you might make some fine-tuned adjustments with the trim. Unlike with optical zoom versus digital zoom, the trim actually doesn't sound bad. It's okay to trim things up and trim them down, but it's good to keep in mind it comes after the gain in the signal flow. The gain is the actual preamp. The trim is just a digital control. Yes, that's.
With fully digital signals, there is no.
Yeah, fully digital signals. The preamp is not used.
So it'll be just trim. So like in Chapel, our wireless microphones are now run through Dante, which is audio over Ethernet, and so they're fully digital. And so there is no gain setting. There's only trim.
No.
Yeah, so when you're running the Chapel board, don't be thrown off if you're looking at a channel and where's the gain? There's no gain. We're not using a preamp. You gotta use the trim.
Cool.
It's not needed.
It's not needed. Yeah, so your channel strip is accessed by selecting the channel, and then these controls will control that. And you can tap on the screen to pull up different visuals of the different things. Unlike on an analog board where you have a dedicated fader for each channel, none of these faders are dedicated controls. You have different pages or tabs, or what they're typically called as layers. So this layer might be controlling one channel, but then if I go down to this layer, it's controlling a different channel.
Right.
And it's just a more compact way to arrange things. If I have 64 channels, rather than having this really long console with 64 faders, which is what you would have to have with an analog console, it can be more compact, and I can just have like, I think this is 21 faders, 25 faders, I guess. But I can have 25 faders that can all be assigned to do different things depending on which layer you're on. So maybe layer A, maybe if I have 64 channels, maybe layer A is the first 25 and layer B is the next 25 after that. Or I could assign them to do all sorts of things. I could make this a bus. I can make it like a mix or a group or an effect. I could have duplicates. I could have, this is the vocal channel, and then down here this is also the vocal channel. So you can really do a lot of customization in how the board is laid out with a digital board, and it's all compact. You just page through different things. And I'll walk you through some of the routing here, how you do that.
Tim, you're in front of the shot.
What's that? I'm in front of the shot.
You said
What? I need to see what I'm doing. So here's how this works. If I want to make, let me go down to a blank layer here. Let's say that I want this fader to be channel 1. So I can go to setup, I believe, on this board. One of the drawbacks of digital boards is they're all different. You have to relearn each one. Analog boards, I mean, there's some differences, but it's pretty much all the same. You've seen one analog board, you've seen them all. But for these digital boards, there's different layouts, different menus. So sometimes I'll have to relearn where things are at. But basically, if I want this to be channel 1, I can come up here to setup. I find strip assign. That's what I'm looking for on any digital console. I'm looking for my strip assign. And then down here, you see all these blank channels. That's what I'm looking at here. This is blank, this is blank. Up here, these are the available channels. So if I want this to be channel 1, I can click channel 1 there, and I can drag it down here, and now this is channel 1. And so I can drag different things in and set up my channels the way that I want them to be. I can also drag mixes or buses down there. I can, if I click mix, I can drag, say, a drum group over here. So now this is a drum group. I can drag an aux in there. Now this is an aux. I can drag my master bus in there. So now I have an extra master bus right here. See, same channel. They're controlling the same thing. So yeah, you go to your surface, strip assign, and you can drag things around and customize your layout as desired. One thing that board doesn't have, that this does have, is DCAs, which is a digitally controlled amplification. Some analog boards have what's called VCAs, which is voltage controlled amplification. It does the same thing. That board didn't have it, so I couldn't show you it there.
Sounds like a preamp.
No, I mean, it does, I guess, provide some amplification.
Right.
But what it does, it is not a bus. It is a remote control. I'm going to drag a DCA in here so I can show you. So what a DCA is, I can assign different channels to this DCA. And then if I put the fader down, it's like a remote control. It's going to take the volume on all the channels that I've assigned there, and it brings the volume down. Or if I bring it back up, it's going to bring the volume back up. But it's not a bus. Nothing's actually getting on the bus. It's just a remote control. It's just adjusting volume back on those channels. And because it's not a bus, a DCA doesn't actually go anywhere. There's no destination for it. And there's no processing for it. So you can't EQ a DCA or compress a DCA or route a DCA anywhere. It's not a bus. What would you use a DCA for? Well, a good mixing strategy. I don't always like using DCAs and groups together because it can get kind of confusing where you're using your groups to control things in the DCAs. but it can actually be really useful on a large scale show where you have so many channels and you really need to simplify your workflow. So a good strategy on a larger scale show is you compress everything. You get everything compressed so that you don't have to move the individual channel faders a whole lot. And then you go over to your groups and you mix your groups and you get your group faders wherever you want them to be. And then if say I have a group that has guitars on it, or a group that has announcement mics on it maybe, and I have them mixed in a certain way. I have my group fader where I want it to be in terms of the mix. Well, what if there's a part of the show where I don't need those channels and I need to mute them or turn them down, but I don't want to mess up my mix? Well, that's where you could use a DCA. So I can leave my group fader where it is, I can leave my mix the way I had it, and I can use my DCAs to turn everything down and then bring it back up. And as long as you're consistent on where your DCAs are, like leave them all at unity and always return them back to unity, you can use that as a way to mute things and turn things down without messing up your mix. So that's a good use of DCAs. But it doesn't always make sense on a smaller scale show where you don't have so many channels, and it can just get kind of messy and confusing when you have so many DCAs and groups. That makes sense?
Yeah.
How well it works. And then let's just go over routing a little bit. So you can customize what's going on in each layer by going to your strip assign and dragging and changing things. Routing, man, every board's different. I'll just show you what to do on this one, but it's gonna be different. Yamaha, Behringer, Personas, SSL, Digico, it's gonna be different. Even from one Allen Heath board to another, it's gonna be different. But what you do on this board,
They have no integrity.
they have no integrity. Yeah. What you do on this board is you click select, there's a routing button, and now this shows me all of my buses. So I have my main LR there, and I have a bunch of different mixes and groups and auxes, and then there's an on button for each thing. So to get a channel onto a bus, I have to press on. So that kind of takes the place of the buttons that you had next to the faders for like stereo, group 1, 2, group 3, 4. Instead, you just have them all laid out here under the routing menu, and you turn on, wherever you want that channel to go, what bus you want it to board. So back to my example over there, if say I want everything to ride on the master bus, well, I select and I turn that on, and I select here and I turn that on. Oh, what's going on here? Oh, that's a DCA, that's why it's not working. That's not the channel. I turn that on and I can just kind of scroll through and turn them on. Or another thing I can do is, does this have it? There's usually like an assign button. Yeah, here we go. So over here I have all my mixes. I'm on the main mix right now, so then if I hold down assign, the select buttons light up that are assigned to that mix. So I can, those are DCAs, that's not gonna work, but I can hold down assign and press all these buttons to assign them to that bus. Now they're all riding on that bus. But then what if I want to assign some of them to a group and I don't want it to double route? Well, I can come up here to the routing menu and I can turn them on in that group, or I can find the group somewhere over here. And I can go to routing. Or maybe this one doesn't work that way. Yeah, boards work differently. Anyway, Allen Heath boards, you typically have mix buttons and then you have an assign button. So whatever mix you're on, you hold down assign and then you can select the channels that are going to go there. And then make sure that you don't double route it. If I'm going to route something to a group, I want to make sure that the group bus is riding on the master bus, but not the individual channels, right? That makes sense. And there's usually a couple different ways to route. You can do what I just showed you. You press the mix, you hold down assign, and you click through the channels. Or you can do it up here if you go to the routing menu. You can click and assign different things. So yeah, you route like that. It can get so confusing, especially because it's all digital. You're not physically tracing any cables. When you're on a new board for the first time, definitely take some time to get to know the routing, get to know how you decide where buses are going and how you get things onto the buses. That's important.
Learned from my experience. I did a memorial service a week ago at my church. I was on a scene that I previously saved a scene that got deleted, so I was on just a default scene. I knew the podium microphone was on, I was getting signal. I knew it was routed to a DCA somewhere, because I could not find the DCA. And so I couldn't turn it up, and I just couldn't get the podium. So I had to just start from scratch and go to the factory defaults and then build everything from scratch.
Oh my gosh.
Luckily it was only 3 microphones, so it wasn't a lot to do, but I had to find out where the channels were because they weren't labeled when I went to a new scene. And so yeah, kind of a headache. And it was routing. Routing was the problem. It wasn't anything to do with signal or gain or plugging things into the right place. It was just inside the console, the routing was the problem.
Was that in the middle of the show you had to do that?
Right before.
Oh, wow.
It was right before there was a funeral, memorial service. So I had everything else working. And so the only thing that wasn't working was the podium mic because I hadn't tested it yet because no one was there to test it. And so we were about to just switch to A&L. But when I had previously done an event, I started from scratch and set everything up. So I was I know I can do that. I know where the channels are. So I had 20 minutes. So I switched it over. I got it working. I had my channels. I had time to label and everything. Later in the show, there was a keyboard that we used, and instead of the piano, I forgot to set that up because we tested it, and turns out it needs phantom power with the DI we were using. And so he goes to play the keyboard, and no sound comes out. I'm oh. And so by the time I get to where I can fix it and get it turned up, he's on the piano. And so it was an audible was called in the middle of the thing, but definitely I wouldn't have had that problem. I had it all working. It was just the routing on the one microphone made me switch at the last minute. So yeah, it caused big headaches.
Now that's both a routing and a strip assign thing, because it could be that DCA that you can find wasn't on the strip
it wasn't anywhere. Yeah, because I don't think they never used that microphone.
Right.
And so I don't think they had it on the strip. Because I went through all the layers, couldn't find it anywhere. I turned everything up, nothing. So
that's something I'm always afraid of when I'm setting up scenes. What if there's a channel that's feeding back that I didn't put on the strip assign?
Yeah.
And then someone's on the board that doesn't know how to go through all that.
Right. Yeah, it is. It can be a real headache because you can't do the okay, this cable goes here, and so now I know you can't physically trace it. You have to just make a mental map of where everything goes, and you can look through the channels or through the settings on the board. So yeah, it can be a big thing. And that was a Yamaha. And so yeah.
I don't like it on that board.
I didn't really like it. I really like it either though, everything is so different. The things are functionally still pretty much the same, but the way it's laid out and the way you mess with things. What?
This board.
Yeah, I mean it has a lot of the same features of the on instead of the mute over there. And it has sends on fader instead of assign or whatever for what goes in the mix. Yeah, I don't really like it.
So they should just stick with pianos.
That is, yeah. That's the thing is I got it figured out, but it wasn't fast enough in the moment. And then so you did 2 songs back to back, and then there's a third one later, and I was I haven't figured it out. But he was too scared of it to try it. And so he was we'll just do piano. So yeah. It worked out, but it's also better, if you have more rehearsal time and practice time, and it was a 2-person job and lots of other things. But
right.
We have all those problems fixed here for the most part. We have enough people and usually give you enough time to check things, and that's why we have the 2 hours before doors open or whatever is when our call time is, because like to figure out all those problems if you have them, or 3 hours or whatever. You don't always need that time, but when you do, you really need it. If I had 30 more minutes, then I wouldn't have had any of those issues. But that's the time I had, so. Yep.
Get to know the routing, get to know the script assign on your board. That's more important than learning the processing, because the processing doesn't change a whole lot from one digital board to another digital board. EQ is EQ, but routing is not always the same.
That was like my biggest, when we did the pop rock concert, my biggest hurdle was like figuring out the routing, and
I really like
how
routing
to
on that
do
one
things.
either.
No,
Yeah,
it was so weird because like you had to push 3 buttons.
And there's no touch screen.
Yeah. And so, it was like one of those sends on fader or whatever, like assigned to this, and so you push this, and then to like get into the setting to where you can do the assigns, and then you push this button to select which channel, and then you push this button to select which mix it goes to. And it's like, once you learned it, it wasn't that complicated, but if you don't know, like, it would take me so long to figure it out. If Tim hadn't been there to show me, it would have taken me forever.
Yeah. So there you go. Routing, signal chain. You probably want to know how to do effects. Everyone wants to know how to do effects. So I'll show you effects real quick.
100%.
On each channel, you can do an insert effect, which you could actually run as like a physical insert, like on the analog board. But by default, it's and if you were to do that, it would be the exterior input, mix exterior in. I'm on a group. Hold on. On your signal chain here, on your channel strip, you'll see the preamp and the high pass, and you'll see a grayed out thing called insert. So I could make it like an actual physical thing. If I go up here to this window, I could like pick local socket, or you could just use the internal effects processor and it'll function as an insert. So I could select effects unit, and it automatically populates on the send and the return effects unit 1, and then if I jump over here to effects, there's effects unit 1. I can pull up different effects by going to the library, which is here, and then there's different presets for different effects, reverbs, delays, and all that. And that's how you page around to different kinds of effects, different kinds of reverbs or delays. A lot of them we don't have. We have to buy them. It's an expansion pack. Yeah.
Spend how much on that, and they are charging?
And it's like $1,000.
You want more?
That's crazy.
That's how you get it digitally. You can't just buy the box. You have to like,
Easy way to make more money.
I mean, yeah, I guess so.
The one in HKP, I don't know if we bought the expansion pack, but there's so many effects on there you can use already there. It's pretty cool.
That's great.
But yeah,
Is
so
it not enough?
then you would do the least amount of live music.
right.
What do we have on this?
One day they'll use our system. So you can do insert effects. You can also do kind of like I was showing you here, where you can put it on a channel and you can control it with a fader. So for that, again, you go to your strip assign and you got to find your effects. And so I could have like put a blank layer down here. I could put my reverb return there and my reverb send there. So now this is the same effect. This is the send. So this is sending out to the effects processor. If you picture like an actual effects processor there, it's going out, and then this is the return. This is it coming back in. And then how I route things there is the same way as all the other buses. You select the bus, and you can either do it on the screen by pressing routing and turning things on, or you can hold down the assign button and put it in there. So that's just the way to route anything, on the screen or using the assign button. So that's how you do effects. I/O, that's a good thing to go over. This is another thing that will change a lot from one board to another. I/O stands for input output. So routing is like where things are going, where buses are going, what's assigned to which bus. Input output is like physically where are we getting our sources from? Are we getting it from where's my microphone? Oh, here it is. Is it plugged locally into the back of the board, or is it plugged into a snake, a digital snake? You can select that here. So like I have up at the top, I have different tabs. I have local, I have S-Link. So I can select inputs here, and I can patch kick as local channel 1, and then I can go over to S-Link and I can patch snare as D-Snake channel 2. So now if I do that, if I go to my channel strip and I drag channel 1 into here, that is now a local channel. So it's expecting something plugged straight into the board on that channel. Whereas for channel 2, because on the I/O I set that to S-Link, which is the digital snake, if I drag channel 2 on here now, well, I can't plug straight into the back of the board anymore, because now that's no longer local. I actually have to use a digital snake for that. That's another thing that will catch you off guard sometimes. You're wondering, well, where's the signal? Everything looks correct, but I'm not seeing any signal. Well, is it set to local, or is it set to the D-Snake in your I/O? That's just a good thing to be aware of. I pretty much always patch things 1-to-1. So channel 1 is 1, channel 2 is 2, channel 3 is 3.
That's always nice.
1-to-1 patching, that's the way to go most of the time. There may be some situations where you'll patch things differently. But yeah, just be aware of the patching in
I say
and out.
just put everything random places because it makes it more exciting.
You could do that. Would make things more exciting, that's for sure. There's also soft keys and soft rotaries. These are assignable keys, so you can make them do whatever you want them to do within whatever options they give you. So if I go to setup and I go to soft controls, I see soft key 1 up here, which is right here. And then there's a list of different things I can make that do. Right now it's unassigned, so this isn't doing anything. But I can turn it into a channel mute, so I can make this, maybe there's a certain channel that as I'm paging through things, I don't want to lose track of the mute button for that. I can assign this as a mute key for that, so I always have access to the mute. There's all sorts of things you can do here. You can make it a tap tempo for your like delay effects. You can tap that into the tempo of the song. Right now I have these custom rotaries set up as groups. So you always, no matter what layer you're on, you always have access to your drum group, your instrument group, your vocal group, your handheld group, and this is the mutes for them. So that's pretty helpful. Yeah. What else should we go over? We got the soft keys. I mean, we could dive so deep into this. Do you guys have any questions about any of this? Is there anything you're wondering how to do it on a digital board?
There's actually I had a question about the compression.
Yeah, the compression.
So I remember you saying that you can set the compressor to like compress when certain frequencies hit it.
Yeah.
Isn't that just like a multi-band compressor?
It is, except it's only one band.
Right.
For side chaining like that.
Okay.
Yeah. On your master channel, a lot of analog boards have what's called a graphical EQ, and it's usually like in the corner, on the right side of the board, and that's like a master EQ for the master. It's got like all these little sliders on it, and you don't have control over width or which frequency each slider controls. It's all fixed, but there's a bunch of them. It might just be 9 on a small analog board. A bigger analog board might have a bunch. There's actually, I'm gonna step out of frame. But we actually have a 31 band graphical on here. Probably clipped like hell there.
That's okay.
Yeah, so that's a graphical EQ. On digital boards, typically every single bus has a graphical EQ on it automatically. So for example, if I come over here to my main bus, there you have it, graphical EQ.
Cool.
And if I press fader flip, well, now the faders are controlling the graphical EQ, which I think is.
And so is the graphical EQ just like, it can be just a substitute for like the normal parametric EQ one?
I wouldn't use that as a substitute.
Gotcha.
Really what it's there for is for system tuning.
Okay.
So you could use that to eliminate frequencies that are feeding back and to set the tonal balance of your system and optimize that. Yeah, I wouldn't use that as a substitute for your parametric. Sometimes it can be pretty convenient though. If you put a graphic EQ on a channel as an insert effect, we have more bands to work with, and so sometimes that's faster if you're trying to find a certain band instead of like working all the 3 different knobs to try to find it. You can just find the frequency you're looking for on there. So it can be pretty convenient, especially on a digital board where it's very easy to move these faders. And so I can draw little shapes. I can create.
Whoa, it's a mountain.
I can create a little bell curve there. You can do that there too. It's just there's more resistance in the action of those faders. Dylan, can you think of anything else I should go into? I mean, there's so much. I could go into USB recording, but I don't know what would be useful just to get us going.
Yeah, you talk about mixes. I mean, it's kind of the same thing with like mixes and groups, like just turning them up inside of that relative to everything else. Is there anything that I can see that would be helpful? Seems pretty straightforward. About like, did you show them channel routing?
Yeah.
Yeah.
Oh, I guess I didn't show the source
like
select there.
Yeah.
Yes. So I showed you the I/O screen, but another thing you can do, and you'll be doing this on events when you're setting up. You're running the board, and your stage tech is plugging things in, and stage tech will give you an input list, or they might call things out to you like, "Oh, I plugged in the kick into channel 7." So now I can go to my select. I can select my channel here, and then up here under source select, make sure I'm on DSnake, if it's plugged into a DSnake, and then select channel 7. And now I've patched it correctly according to what he did down there. Or if instead of plugging in the channel 7 down there, for some reason I decide to plug the kick into channel 7 locally, I don't know why you would do that. I can also adjust that here.
Boards or an event and you run everything like locally or whatever.
Yeah, or if you're doing an analog snake, technically that's local.
Right, yeah.
So that makes sense? Is there anything that you guys are fuzzy on with digital consoles? Does it make sense? What's the first thing the signal's gonna hit?
Not the preamp, because there's no preamp.
Well,
But
there could be a preamp.
If there is a preamp.
If there is a
If there's a
preamp,
preamp,
the first thing it's gonna hit is the
Yeah.
preamp. If there's not a preamp, what's the first thing it's gonna hit on the digital console?
Processing.
Before the processing or something else?
Compressor?
The trim,
The trim.
the digital
Yes.
amplification. And then then you get into your processing.
Right.
Yeah.
Is compressor part of processing?
Compressor is part of processing, that's dynamics processing.
Okay. Right.
And the gate is also considered part of dynamics processing.
That makes sense.
When you use a gate as an expander and you're turning down volume below a certain threshold, the effect psychoacoustically is that there's a greater range of expression now.
Alright.
So yeah,
That's
it
cool.
cleans up noise and also expands the dynamics.
This is interesting.
Yeah. Well, any other questions?
I like so.
Cool. Then I think we're good. Let's stop the recording, tear down.